Okay, so we talked about introduction to functions the last time, and we talked about the two different types of function. A function that does not return a value, that's a void function, and then we have a value return function, which we've been using since the beginning of the semester, since we started writing code. We talked about the function parameters we've been using in class, and then I was asking you to pay very close attention to how functions work in memory. And we talked about the different memory as a whole that a C++ program gets while it's running. However, we're going to focus on the stack and heap memory. We'll talk a little bit about global memory, and then next week we'll talk about some other kind of memory, static memory. And then I was showing you how variables load into memory. We'll take a deep dive today into that. And we will use this stack activation records to plot code onto this record and then show you how this record loads onto the stack. And it only loads onto the stack. So say main, if you think about it, main is going to be on the stack for the longevity of the program. And it's going to be there until right before our program either crashes or we close it. All the other functions that we call are in memory while they're executing. Like if we call a function display, then while that function is executing to display something to screen for us, then it's in memory. And then once it displays, then it exits and then it's removed from the stack memory. So we will go through two examples that cover activation records, and that will introduce you to the types of variables we use in C++, and those are value parameters, value parameters, and reference parameters. We'll start with, let me erase this because this was for the other class, and actually right now it probably won't make sense to you all. So we will redraw these diagrams with some code, and what I'll do in main is I'll write code to create a variables that you've been comfortable with from your Python days and from this class. And then I'll show you like what you already know, but now we'll talk about them in a technical way, and you'll be like, oh yeah, like that's how they work. I did talk about default arguments. I said static variables next time, and we won't worry about that. So today we talk about value parameters first, and then we'll talk about a special kind of variable, a reference variable, which is a clone to an existing variable, and it can get read-write permissions to that variable, meaning it could be like its evil clone, and we can overwrite data in the variable that it clones. And then we'll see how this concept of reference variables work in functions, and how we can use a reference parameter to pass data into a function. And we'll explain why we need to have different types of variables in programming. Okay, so let me see. Can you share your screen? Yeah, I can share my screen. So, okay, so you all weren't watching me erase all the mumble jumble. Okay, diagram called by value, right? So this one I have to erase because usually it doesn't make sense if you just see the final product, right? Unless you're a genius, then it might make sense to you. Okay, so let me open Visual Studio and we'll write some code in main. So I think this was Okay, so file, close folder. I always get the source codes mixed up, but it's all right. So let me see here. I think you all says -1, but I used -1 yesterday. It's okay. Okay, so we go to main, and we want to go to 04 module 05 main.cpp. So when we create a variable in C++, that has its own address in memory. And then I can create another variable. And without me telling you anything here, hopefully, you understand that num1 and num are two different variables. Here I create num and I assign it the value 5. Here I create num1 and I assign it the value that num has. But how does the value from num get into num1? Anyone? No, we have it here. Like I'm showing you how we get it, but I'm like, think what happens in think logically. What happens? Num is 5. No. Don't. Just a simple word, right? So it does not copy the address. The value 5 is copied onto num1, right? So if this is 5, then the value 5 is copied to the num1 address. Okay, copy. That's the key word. And are these variables the same? Is num1 the same as num, even though, I mean, from that statement 6, are they the same? No, they're not the same variable. In memory, if we would map those on the stack, this would be num1 right there, and then num2 would be here. Of course, there would be some more items over here for the loaded memory. This has value 5 because we assigned it the value 5. Actually, this is num, right? And this is num1. Let me make that clear. Okay, so let's erase the 5 and backtrack how this works. So we create the variable num, auto num, and then we say equals 5. But the first thing that happens is we get a memory block, 4 bytes. 4 bytes of memory here. And what's in memory? Like, what's in memory initially? We don't know. Like, whatever was used to store data in that memory address before is there. But instantly we overwrite it with 5. So whatever was there is overwritten by 5. Meaning there's something here. As soon as we create num1, there's also something here. But as soon as this statement, this right-hand piece executes, after C++ is like, okay, I'm going to give you an address. And then we're like, yeah, copy the value of num to num1. And C++ is smart enough to know, oh, 5. So let me copy 5 over here. So now I ask you again, are they the same variables? No, they're not the same variables. And there we can see that both of them have their own block of memory. So they're not the same variables. And we know that 5 was copied, the value 5 was copied from the 4 bytes block of memory to num1's 4 bytes block of memory. So it's copied, and they're not the same. Okay, so knowing that, let me erase this, and then we go to value.h, And then we're like, okay, write function prototype for pass by val and ref with a value int and ref int parameter. Okay. Void pass by val and ref int num. For now, pretend you don't see that ampersand, okay? Num1, num2. I'll come back and explain this piece in a little bit. Actually, maybe we should do this, right? To avoid any confusion. Okay, and then we'll modify the function. Okay, so then we come back here and we're like, okay. Void is a function that does not return a value. So this function does not return a value. Okay, so assign 20 to num1. Okay, num1 equals 20. Okay, that's the code, but now we want to go back into our diagram, and I will erase this stack, and we want to go into main. We want to include value ref, control space. Okay, and then I want to call pass by val and ref. I need some value there. I'll say auto num1 equals 5. Now I can use num1 here as a function parameter argument. Okay, let's diagram this using a stack activation record to get a diagram which will help us understand what's going on. Okay, so we have a auto num equals 5. I should have written main first. So int main, open close curly brace, auto num equals 5, and then pass by val and ref function is called using num1 and return 0. Okay, we need the stack. So let's see, activation record 4. So those are stack activation records, and you'll see why or how computer memory works, but that'll help us understand what's going on. So this is the activation record for main, and this is the activation record for pass by val and ref, and then we have the stack memory. Okay, so if we go back and look at activation records, there's a lot of stuff going on here. Like we have to save main state, the state for main, the return value for main, function arguments, the return address. So if you think about it, like return address will help C++ in memory know where it left off. Like when a function's called, right, that function is in a different region of memory, so C++ has to remember how to go back after this function executes. So that's what return address means. EBP base pointer, so this is memory. Okay, this is memory on the stack, but we just make it bigger so that you all can see like what's loaded onto memory. So base pointer keeps track of memory only in this activation record. It knows how to find the return value. It knows how to find the function arguments. It knows how to find local function variables. Okay. So local function variables we will map them, right? So for our example, we are interested in return value, function arguments, and local function variables. That's all we are interested in, okay? So let's go back to our diagram here. So what's the return for main? Right now it's return 0, right? So the return is 0. And what about function arguments? There's none. If we go back and look at main, look, there's no function arguments. What about function local variables? We're going to write them in this area here. We go back here and we have exactly one variable. So we have auto. Actually, I don't want to write the whole variable. Let me backtrack here. Let me draw some lines. So assuming that would be, this is 4 bytes and this is another 4 bytes, so 4, 8, assuming then the address ended in 8, right? So then here we have num1 with the value 5, okay? Okay, so now that we understand this, our program starts running. Poof. We run it. I said main has to be loaded onto the stack. So this activation record is loaded onto the stack. So this would be the main function memory block, right? And it will get its own memory block here. And the activation record goes into this area, okay? With an address for 0. There's no address for function arguments, well, because we don't have any function arguments. And then we have 5, right? So assuming that this would be the return value 0, and then maybe there was like a buffer for whatever, and then we have num1 equals 5, right? So this would be 4 bytes, and this would also be 4 bytes. And that's how main would be more or less in memory, right? Okay, let's go back here. So main's running, num's already in memory. This function needs to be executed. However, before it's executed, an activation record has to be created for that function. So we have the return function arguments, and then we have the local variables, so local function variables. Okay, so we go into this function and we want to see, okay, it has an integer type num1, okay? So we draw some, actually that's the function argument, so it would go here, and let me use a different color. So this would be num1. At the moment, we just reserve an address in memory. We don't, like the compiler or the program doesn't know what value num1's gonna have initially, but it will eventually. And then we have local variables, so let's look at local variables. We don't have any local variables here, right? But that's okay. Maybe let's just create one just to make sure that we understand what's going on. So we'll name it num, and we'll say 20, and then what we'll do is just we'll say, well, let's give num1 the value of num, right? So now num1 is 20. So then here we would see num with a value of 20. And then by this time, the compiler will know what the value of num1 is. What's the value? 5. But how does the 5 get here? It's copied from this address to that address. Okay, remember I created, when the class started, the diagram without all the detail just to show you that there's two different addresses. So now we're like getting the bigger picture. So this is 5. And then this is loaded onto memory. And it gets its own memory block. And we'll use a different color for this one. So let's assume that num1 would go here with a value of 5. Notice right here, num1 and num1, two different addresses. So is this num1 the same as this num1? This one right here on line 6. From the diagram, are they the same variables? They are not the same variables. They are on different memory addresses, and your next question will probably be, well, how does it know that they're not the same variables? Well, remember, this is main's memory right here, and then over here this is pass by values memory. So pass by value does not even know that main exists, and main does not know that pass by value exists. Main knows that some function's executing, and maybe it does know that it exists, but it doesn't care about its internals. The only thing main cares is, hey, pass by value, when you exit, send me the return address so that I know how to continue executing. But that's like for the assembly language class that you will eventually have to take. So that's why we can clearly see that they are different. They're in different activation records. Okay, and then we need space for num equals 20, and let's say that that one would be here, like num equals 20. So from here we should understand that main cannot or does not know that num exists. It doesn't know that it exists. So main cannot access num. It doesn't know what num is, even though we visually see it, but the way programming works in memory, it doesn't. And num1, this one here is this num1. Even though here it seems that we're like sending the variable into the function, we're not. We're just saying, hey, use this as your function parameter, and then C++ is like, oh, okay, you want me to get the value that num1 holds. And then it gets the value that num1 holds, and that's why it gets a value from here and puts it in its num1 for pass by value. And now you can see here they're different variables, and then we can go here and they're still different, and they'll always be different. Okay, I purposely named them the same. The name doesn't matter, but I named them the same just to drill the point home that when you use parameters like this, which is call by value, you're sending value, but copies of values into the function. Okay, you're not actually sending the variable into the function. Yeah, it's out of scope, right? So pretend this piece doesn't exist. We start a program, boom. Program starts, creates this, activation records created, main's already in memory, main's in memory here. And then we're like, oh, let's call pass by val and ref. So now pass by val and ref is in memory temporarily, like that function executes in milliseconds. So main can't go in there and know that this guy exists. Doesn't know. Like, there's no way we can access this auto num variable. And I showed you, right, with the code, it's like, I don't know what num is. Okay, so then the function finishes executing. Actually, we're doing something in the function, right? We are saying num1 is num. So let's go back to here, and we're like, okay, so hey, you num1, your value is not 5 anymore. It's 20. That value is copied. So 20 is copied to this address. Okay. So that's how num1 gets the value 20. But if we go back and look at memory, this num1 still has its value 5 because it's a different variable. Okay. So then the function starts exiting, and once it starts exiting, then this block of memory, maybe like this, will be removed from memory, and these variables, they don't exist anymore. Okay, and this activation record, it does not exist anymore. What's passed to main is the return address, so main and main state, which we did in diagram. So that way main knows like how to continue executing. So then we come back here, this executes, and then it comes to return 0, and then main starts exiting, and then main will be removed from memory, and then our program is not in memory anymore. So that's a very good example of last in, first out. Main was the first one in because it's the main program for the main function for our program, and then from main other functions are called. And this was the last function. Pass by val and ref is the last function called. So by rule, it has to go out of scope before main. And it makes sense, right? Because how could this one continue running if our program's not running? So that's why it's a last in, first out structure. You see, this was the last in, but it's the first out. It finishes executing out of memory, main still in memory temporarily. Once it exits, then main's removed from memory and the stack's free from memory. So questions about stack and call by value, or sometimes you'll hear the term pass by value parameters. Any questions here? Okay, so okay, here's the question. So when you copy a variable value within function stack memory, it copies from the stack memory, not the main memory, unless you're using a global variable. Well, global variable will get it, even the stack is main memory, right? So all of it is main memory, but we just call it the stack. So if we go back to, where did I have the stack here? See, like global, it's memory, stack is memory. This just has its own region of memory. So it'll copy from global memory, but to simplify it, it copies values from an address, right? Global and stack and static variables, they copy from a region of memory into where we are. If we are using values, like I showed you at the beginning, we have another variable here, auto num equals num1, then it's just copying from one address to another address. And even if it's a global variable, it's doing the same thing, like it's copying from an address into our stack. So okay, so we come back here, and then so that was the whole theoretical portion, but remember, I always say don't trust a programmer. So I'm going to do this. Okay, I'll explain this in a little bit, but I have to validate this with our friend, the test case. Okay, So let's create a test case to make sure that what I just explained and diagrammed is the case. So let me collapse this one here. Examples for test case test called by value, a copy of a variable's data is sent into the function. Okay. So how do we test this? Well, we know we need to create a local variable. Auto num equals 5. We'll name it num1. And then we cannot test this function because we do not return a value. But what we want to test is, we want to test, can I change this variable in the function? So then I can say, okay, pass by, and it has no idea what that is, meaning I'm needing to include something at the top. So include always 100% of the time, include .h's, okay, header files. .h, and then we come here, control space, and then it gives us the code help, tab, num1, okay. And we look at, actually we need another parameter, we'll just say num1 twice. Why do we need another parameter? Because I added this code that we've not seen up to this point in class, but I'll go back right now and explain what the heck that is. Okay, so we go back to the test case. So what do we want to test? We want to test if we use num1 as a parameter, if the value's changed. That's what we want to test. And maybe I have to use num2 here, just to not confuse anyone. Okay. Okay, no questions. Okay. So I want to test that it doesn't change, meaning num1 has to equal what? Right there. I want to check that num1 doesn't change when I use it as a parameter, so the value should be 5, right? The value should be 5. So even if I call the function and pass it in here, for us to validate that all this diagramming is what's actually happening, we can have our friend the test case help us. So we can say, okay, I have the test case ready to go, and now I can run it. Examples, run in terminal. Yeah, and I'll take questions while this is linking, because sometimes it takes a while. So if you have any questions, and I can answer them right now. Okay, so everything's hopefully making sense. And it's still linking. Okay, so by now we know that green is good. So when you call the function in the test case before required, it's testing the argument in the function. No. When we call the function, let's see what happens. Pass by val and ref. Okay, it's like, okay, where can I find that function? Oh, it finds it here. And then here we are purposely using this num1 to try and override it with some value, in this case the value of num, which is 20, in the function. And then the function starts exiting, and then it continues into this statement. So now we're like, did the function change num1 or not? And if it changed num1, let's see what happens. It didn't, right? Like once we run this test, we know that num1 is still 5. You see, num1 is still 5. So then that should make it very clear that this num1 is not this num1. And then we go here. So then this num1 is the one that got changed and not this one, right? And maybe in this diagram I should do this. So that one's that one, and then this one, num5, is that one. So they're two variables. A require requires a Boolean expression. So whatever makes a Boolean expression is valid. Right, so we don't have to call a function here. Like, as long as this evaluates to true false, then it's valid. Okay, that was interesting. Okay, so let's go back to some source code. We go to main. Can you hear that? Can you all hear dogs barking? Or no? Nope. Okay. Well, these are pretty good headsets then. I was wondering. Let me see here. Too few arguments. Okay, yeah, that's right, because we need another variable here. So for now, we'll do that too. Actually, I need to comment this out. Okay, I can hear my dogs barking, but I guess the headset filters out that noise. Okay. Okay. So we know that this creates a variable on the stack. And then I'm talking about a special, at the beginning, right? I'm like, we're gonna talk about a special reference variable. And that's a variable that can be a clone of an existing variable, like this one. So this is an existing int variable. So I want to create a clone. So I'm like, okay, so let me create a clone, and I'll name it num_ref of num. We'll eventually write the test case, okay? But right now, I think if I stay simple, then I can get the point across better. Okay, so then I'm like, okay, so let me, value of num is num, new line character. And then I go ahead and repeat this, but then I say this one is value of numRef. And then I have to change this to numRef. Let me think here. Okay, let's put this on pause first. Because if I run that code, it probably won't make sense. Okay, so what I'll do first is I'll pretend this one doesn't exist either, and then I'll be like, okay, value of num is, hold on, okay, so you understand why I did that. Okay, so we know that one's gonna output 5. We know that without a doubt. And I keep on telling you, hey, this guy, variables are loaded onto a memory block. Well, nobody so far has asked me, well, prove it, right? You're just taking my word, and you shouldn't take my word. So then we come here and we're like, okay, we'll prove it. Okay, so address of num is, so with this reference symbol or ampersand symbol, we can query the address of an existing variable. So let's run this program and see what happens. src examples module 4 value and ref, and we run it. Value of num is 5. Address of num is some address. See, it's a hex number. What's this value? Honestly, we don't care, but that's a memory address. So meaning this num has a memory address that we can query and we can know of. So from this, we can say, well, maybe now I can create a clone to num, right? So auto numRef equals num. What's this? a reference variable can only be assigned once, meaning once we say, hey, numRef, you're going to clone num, we cannot change our mind later and say, well, now clone some other variable. No, we can only assign it one time. So now let's see what happens. Let me see, do I have that in memory? Yep. Value of num is, value of numRef is, and let's see what happens when we execute this code. Let me put 2 new line characters here. Ones per many, ones per many. Ones per main. Once per variable scope, right? So if it's global, we can only point to a variable one time, and that's it. Again, why do we use this? This allows us to ask a variable, or not a variable, ask C++, hey, give me the address of that variable in memory. So that's why we use this here. And then here we are creating a special kind of variable, a reference variable, or a clone to an existing variable. Let's go ahead and run this. Address, blah. So a value of num is 5. That's this statement right here. Value of numRef is 5. That's this statement right here. Interesting, right? So let's pause here. And are there any questions? What I'll do next is I'll diagram it. The only reason we need it here is for me to introduce the reference variable. Okay, that's why we need it there. Yep. What is the value of valref? The value of valref is queried, and it is 5. Okay, so let's keep it simple like we did for the other one. Let's diagram this. So what I'll do is I'll leave the code, but I will remove this, this, and that, and that. Okay. So that's the same code we have in main, and it's a code without the couts and all the other stuff. We're just focused on creating a variable num with the value 5. And then we are interested in creating a clone named numRef that clones num. Okay, that's what we are interested in. Again, when our program starts running, a block of memory is granted to main. We're not going to worry about activation record for this example. Okay, I'm just focused on getting this concept across. Num gets a memory block. The value is 5. A reference variable does not get its own memory block, okay? I'm pretty sure somewhere in the internals of C++ that's taken care of, but it's not on the stack, okay? So then if we say, okay, so what is num doing? Well, it's a clone to num, so meaning, oh, if it's a clone, then it's also referencing the same address. And it is. That's why when we execute the code, we also get the value 5, because both of them are referencing the same memory address. Yep. Int. Why int reference here? What's num? Integer. I want to create a variable, reference variable. And C++ is very picky. It's like, okay, I will let you create a reference variable, but you have to tell me what data type you want to reference. And I'm like, oh, okay, integer. And once I do integer, then it's like, yes, that's valid. And then C++ is like, now give me an existing variable that's an integer type. And I'm like, yes, here, the num. So that's why we use int ampersand right here. And that was a question on the chat. Okay, so we get this view here. that should make it very clear that this is a clone to num. Okay, so what does that give me? What does that buy me? Well, can I say numref equals 10? And then can I see what happens? Yeah, I can try that. So numref equals 10. What's going to happen? Looking at the diagram. Num, or what value is going to be here? What value is going to be there? Let's look at the code again. Numref equals 10. So is this going to stay 5 or is this going to be 10? 50-50. If you've been paying attention, then you'll get the correct answer. Well, maybe if you're paying attention and you're understanding, right? Because sometimes we pay attention and we're lost. So. I guess it's okay. If you're not sure, just guess. 10. Oh, okay, so let me get that clear. Look at this statement right here, and that's a good question, or a statement by William. Numref equals num. I assigned, what values does this guy take? Well, if we look at this statement here, and then we ran that code, we saw that it outputs an address. From that, we can say, oh, so when I say I want to reference a variable with the ampersand here, then numref will not get the value 5 here. Instead, numref will know about its address. That's what I mean, can only be assigned once. What? Auto num1 equals 10. I can't change my mind and say, okay, now numref clone 1. I don't get an error. I don't know why, but it'll still be referencing that guy, okay? So let's remember to keep that in mind, okay? We cannot change our minds. Of course, if we stop the program and then change the code, then that's possible. But while the program is running, we cannot do that, okay? Let me lower this down here. So I asked if we say numref equals 10, what are we gonna have in here? And student said 10, and that is correct. So we go ahead and run the program. And notice at the end, value of num is 10 and value of numref is 10. So looks like numref not only has read write, but it also has read permissions. It also has write permissions, which can be good, but can be bad, right? So we'll address that in a few. Yeah, so numref will have the same address. So let me see here. Address of num. So here we'll say, okay, so what is numref? Okay, so then we run it. And what's that, 8? Let me make it larger. So num is FF08, and then numref is also FF08, so it's a clone, right? That's a good question also. Questions here on how this works? Okay, so everything's clear, which is good. No one's asked me, why do we need this? Why do we need it? Like, how does this help us with function parameters? So then that introduces the concept of a function called by reference parameter. So I'm not going to check in this code, okay? This is mainly just for demonstration purposes for this concept. So we were here. And then we go and look at our function again, and we have this parameter here. Integer ampersand a reference num2, meaning I want a reference to an integer, and the name is num2. So meaning I want to clone a variable. That's what we're saying. I want to clone a variable. So let's write the activation record, or diagram the activation record for this guy. Okay, so that we can see how a reference parameter works. So we have main, and then we have auto num. What did I name it? Num1, I think, right? Num1 equals 5, and then auto num2 equals 0, and then I want to call pass by val and ref num1 num2, return 0. Okay, that's main. Activation records, we need 2 of them. We need the one for main, and then we need the one for, so this is main, and then pass by val and ref, and then we'll make the stack bigger on purpose. Okay, so return value for main is 0, and then main has 0 function arguments. And then we can diagram local function variables. And from here we can see we have num1 equals 5, and then we have num2 equals 0. So we'll have some memory blocks here, and use this color. And let's say that this address is for num1, the value is 5, and this is for num2, the value is 0. And then we go and look at this code. Our function starts executing. Right before it executes, an activation record has to be created. Okay, so then let's go ahead and do that. I know we have 2, actually we don't have a return variable. We'll do this one in red. And then we have 2 function arguments, so we'll go 1, 2, 3, and we go red. Let's look at the function signature. We have num1 and a num2. okay? So for 100% sure that num1 is here, we don't know the value until the function gets and passes values from here to over here, and then this one will be 5, right? The value of this variable is copied to this variable. We already diagrammed that one, right? But we're going to diagram the whole picture here. And then we have this variable num2, 0. So a reference doesn't get its own memory space, but somewhere it has to exist in C++, right? And I've not looked at the assembly language code to know where it is, but that's okay. What we'll do is we'll assume that the allocation memory is somewhere, but we have to at least diagram it here, right? So we have to say, well, what is this guy's memory address? We don't know. This guy, maybe the address was like Y 104 or something like that. So then this function here, pass by val and rev, has to know about Y104 somehow. So then let's say that it has a special space somewhere, and it's like, okay, oops, what did I do? Escape. The Y104, right? So Y104. But I proved with the C out that it doesn't get its memory scope, so I'm going to put here doesn't get a memory address, okay? But we have to show it somehow, so this is the fine print, but we at least need to understand like, well, how a reference parameter works, okay? And then we go into the function, and we have a local variable auto num equals 20. Okay, so local variables, local function variables, and then address. So then this would be num equals 20. And then this statement executes num1 equals 20. So then num1 right now is 5. So this num1 will now be 20. This num1 keeps its value. We had already gone over that. Okay. And then we have another statement executing, I think, or not yet. Nope. We have to write that statement. We go over here and then it says set num2 to 50. Okay, so we don't have that code yet. So then we're like, okay, num2 equals 50. So set num2 equals 50. So whatever G104 is, we want to change that value. So that value will be changed, okay? To 50. And now I think we have everything we need, so let's backtrack again and let's load everything onto the stack. So our program starts running. Main is loaded onto the stack. It gets its memory block. And then we have a few addresses. We need num1 equals 5. So num1 equals 5. Let me keep the same color to prevent confusion. Num1 equals 5, right? So if you had special computer vision, then this memory block would go in, this memory block here for main would go into the stack here, and then this memory block is going to go over here, right? So that's what I'm doing. Now I'm putting it on the stack. So main starts, and then num2 equals 0, and then we call the function pass by val and ref. It gets its own memory block. So then, assuming it's this one, and then it gets some memory, and it's in memory while that function executes. So we have a num1 equals 20. We're not gonna diagram the reference variable because it doesn't get its memory on the stack, right? But what we will do is we'll say, well, something here references that address block, okay? And remember, this here is an activation record. So something in an activation record references that address. Okay. Num, we need to create memory for that one, and maybe that one would be here, like num equals, actually this is initially 5, right? So let me follow the code statements. 5, and this one's 20. So if I go back to the code, I'm in this step. So now I say num1 equals num, and it's like, okay, oh, num1 equals num, so then you're not 5 anymore, you are 20, okay? And its own pass by val memory region or activation record. And then we go back to the code, and then we say, oh, num2 equals 50. So if we look at the diagram, we know that our activation record is referencing this address. So then you are no longer 0, you are 50. And which variable did we change? We changed this one right here, that num2. So that should now be 50. And how do we do that? Or why does that work? Because we are using a reference, or we are cloning. I'll go back to the questions and see. We're cloning, actually here I don't have num2, so we can match our our written code, num2 equals 0, and I'm using num2 here. So now we are changing that guy's value from 0 to 50 in the function. And we do that because this function parameter here is a clone to that variable. Okay. Questions? Do we have to know how it works for the exam? Yes, you have to know how it works for the exam, because these concepts right here will be used for the rest of the semester. So are there any questions? Like, is it clear how num2 is changed from within the pass by value activation record, right? And let me do this. We're like, okay, so then different color. So you are that activation record, and you are this activation record on the stack. How long is this piece on the stack? Whatever time, and it's milliseconds, whatever time it takes to execute these statements. Once that happens, this one will no longer be on the stack. Our function returns to main here, and then main starts returning and exiting, and once our program closes, then main is no longer in memory. And again, last in, first out. So now we have to do the same thing we did for the first example, which was, well, let's see if this is what actually happens with a test case. So we come back to our test case, and we are okay. Let's create a test case. Test call by reference, and again you will also hear it pass by value or pass by reference. Okay. So we have auto num1 equals 5, auto num2 equals 0, pass by val and ref num1, num2, and what do we want to test? Well, we want to test what the value of this guy is after this function executes. So num2 will be what? What will the value of num2 be? Num2? 50, right? 20, 50, but yes. The point is, it's going to change value, okay? So that's correct. The answer is correct, right? The concept's correct. So it'll be 50. So let's run the test case to make sure that it's the case. So let me see, test, run in terminal, and I will answer questions while this is building and linking and all that good stuff. So questions? I didn't get into details of how the parameters are loaded onto memory. Actually, it doesn't really matter, but if we want to know, they're always from right to left. Let me see, right to left, left, yeah. Yep. Left to right, sorry, so like this. But that's not what last in, first out means. Last in, first out means that the function, so when a program starts, main is loaded onto memory by itself. When this code executes, then pass by val and ref is loaded onto memory right here. And it's in memory while it's executing. It's the last function loaded onto the stack in our program. And once it finishes executing, it is removed from memory. So that's why it's last in, first out. And then main will be in memory for as long as our program runs. And in this case, it's not long, but it's still the last function that is removed from memory because it's a last in, first out data structure. Yeah. That's what last in, first out means, right? So activation records or regions of memory for functions that we use in C++ are loaded onto the stack. All these details here, they're part of the activation record. So that's why I created the activation record first, and then I show you, well, this loads onto memory, and then this loads onto memory. So yes. Any other questions? Oh, I ran the wrong one, or what happened here? Run in terminal. Where am I? Test. Oh, here it is. It's just lost. Up arrow, space, -s, enter. Let's make this larger. So this was the first example for the pass or call by value right there. And then this is the last example, call by reference, where we show that num2 is changed, its value is changed in the function. You see, so initially it's 0. We don't see code here that changes the value of num2, so that means it happens in this function, and I can show you this is where it happens. Num2 equals 50, and it changes because we are creating a reference parameter or variable, or in layman's term, we are creating a clone to num2 which has read-write permissions. That's why our test case is successful and is green. So any questions? Like, I mean, why would we do this in functions? Thinking about memory, why would we use reference parameters, and when would we use reference parameters? When would we use value parameters? If you're thinking about memory, efficiency, and speed. To save memory, yep. So meaning that can also be like, well, to prevent copying data that we don't need to copy. To save memory and time and power. Okay, but now we translate those statements to code, then one question you should ask, well, why didn't you talk about this before? Well, in thinking about saving memory, speed, and efficiency, how large is an integer? Okay, so let me run this code. Two bytes. That's one of the answers on the chat. So let's see here. The size of int is 4, so 4 bytes, right? So an integer is 4 bytes. Oh, that's good. How large is a double? Any guesses on that one? Double? The size of it? 8 bytes? How about a character? Oops, we leave that the same. Size of a character? So a double is 8 bytes, okay? And what's the size of a character? Let's run the code. I won't ask you on the exam like how large is an integer. Oh, 1. Okay. So why am I bringing this up? Well, because 8 bytes to copy in memory is not a lot. So we can use, let me revert this code. So we can use value parameters for integers, doubles, characters, simple data types. But what if we have a list that has 10,000 records? Do we want to pass by value, which creates a copy of 10,000 records, or do we want to pass by reference, which simply creates another variable that references or clones that list, and now we have direct access to the original list location where we don't have to create a copy of the list? So yeah, we want to pass by reference, right? So complex types like strings, lists, vectors, we definitely want to pass by reference, because our programs will run fast, efficiently. They won't bog down, our users won't be mad at us. But that brings up another issue. Anyone want to take a stab at that one? Like if we use a list of something and we pass it as reference, what issue does that bring into the picture? It can be edited. What if it's a list of the payroll that needs to be auto deposited into banks all over the nation, right? If it's like a Walmart corporation, then we don't want to pass it by reference. We want to pass it by value. No, we just said we don't want to create a copy. So what do we need to do to that list in the parameter? What do we want to do to that parameter? It's read write. What do we want to do to it to prevent modification? Nope, I've already said globals are evil. That will make you hate yourself. Constant, right? We want to make them read only. So we can say to the function, I will let you use this payroll data in read-only mode. That way, they don't modify any numbers. So we're being efficient. Our program's fast. We're not doubling up memory for 10,000 records. And we are keeping security in mind by preventing the function from modifying those values. So yes, Kimberly and William, right? We make them constant. So let's look at that example. So we come back to value ref, and in the prototype, write void function for pass by const ref. Pass by const reference. I'm not going to use a list, okay? I'm just going to use a variable. Like when we get to strings and vectors deep dive in a couple of lectures, we'll cover the same examples for those structures. So I want to create a reference to a number. That doesn't give me anything. I mean, I'm doing that up here. I mean, it gives me direct access, but I want to make it read only. So then here I say const. So now I have direct access, but read only protection, and now they can't modify my data. Or I can't modify the data by mistake, right? So now num in this scope right here is read only. So we can say, oh, is it read only? Well, let's see. Right away we get a red underline, right? So expression must be a modifiable L value. What's an L value? An L value is a variable that is stored in an address. So it's saying that this is not modifiable, so we can't modify it. It won't let me compile. If I'm like, oh yeah, well, let me see. So let me run in terminal. Notice it doesn't let me compile, and if I scroll up here, then it's going to tell me that I'm trying to assign to a read-only reference, and it doesn't let me compile. So then I'll be like, oh yeah, I can't modify this. Maybe I can see out it. I'm not gonna do that, right? I can see out num, I can do that, or I can loop through my list and send out those auto drafts all over the nation, and they're gonna have the original or the correct intended value. Questions here with the const reference? So if you don't forget this, you'll be fine. Const reference is my friend. Always. Like, they will save you from unintended data modification to your code. And this concept we will also use for the rest of the semester, the concept of const. Questions here? Test case? Well, I mean, I'm not gonna just change it, so well, maybe in main we can see what happens, right? So we're like, okay, so let me for now comment this out. Pass by const reference num1. So notice here, actually this should be a number, right? And I need two parameters. Well, actually just one. I was thinking about the previous function. Okay, so notice here, oh, what happened? Select the wrong function. Pass by const. Okay, yeah, that's the one I want to use. Pass by const reference. Is this constant? Num1, is it constant? Is it read only? No, it's not read only. So I can change it here, I can change it here, but once it's in the function, it's read only, which is what I'm after. If somebody changes that over here, well, that's on them, right? But my function is doing the intended purpose. Your next question might be, well, what if I don't trust anyone? Well, then make this const. And that way the function's always, I mean, the list is always read only, especially if it's data like that, right? Then force them to access it with read-only mode. That way those checks go out correctly. Yeah, you can say num1 equals 10 because it's read-write in this scope. But once we send it into the function, what are we sending? We're sending the direct location of the variable, but we are protecting our data with const. So if we, so both the function parameter and main are pointing to the same reference, but the parameter is const, so then it's read only, we can't change it. Once the function's exited, this is not const, so it can be modified. But the point being here is that we can protect data in functions by using const, and we can still const references, and we can still execute our programs pretty fast. Okay, so I purposely went 10 minutes over because we need to start catching up. So we'll be doing that to catch up.